I'd like to welcome everybody to our data center cooling optimization webinar. And today the focus is going to be on how to maintain energy savings in the long term. Now, for some of you who haven't taken in any of our previous webinars, we have done a number of webinars on cooling optimization. And the reason for that is because cooling does represent a major expense, a major cost within the data center, ranging between 30 to 60% in some cases. And by looking at reducing cooling, you can substantially reduce operating costs. We've covered those off in previous webinars. We've gone through a number of case studies in the webinars, what our approach is to that and some of the success that we've achieved. And today we want to look at it from a point of view of, once I've done that, how do I maintain that long-term optimization? Because it's very easy to lose visibility on what's happening in the data center, and especially on the cooling side. And over time, inefficiencies begin to creep in and the energy costs begin to climb. I'm Arnold Murphy, CEO and President of SCTi, and we have three other panelists with us today who I'll introduce. Mark Willett, who is the Manager of Engineering Services with SCTi, and our special guest from EkkoSense, Dean Boyle. He's the CEO and co-founder of EkkoSense, and James Kirkwood, who is the head of critical services in EkkoSense. Now, Dean and James will take over the majority of the presentation, and when they do that, they will actually go through a little bit more introduction on themselves and the company. So I'll leave that up to them in a few minutes. So the agenda for today is an introduction to SCTi, talk about our cooling optimization program, and then we'll go through the webinar registration polling results that we had, and a good number of you, I think a very high percentage of you, did respond to the polling questions that we had, which was great. Then we'll turn it over to Dean and James to go through an introduction on EkkoSense, talk about the EkkoSoft platform, and actually do a walkthrough on that platform. And we'll then have questions and answers. Now, as we go through the presentation, if you do have questions, you can put them into the chat link, and we will try to answer those questions as we go through the material. If the question requires a longer explanation than what we can do in a short response to you in text, we will actually address that question at the end of the presentation. A little bit of background on SCTi. We've been around, says about 12 years or so. We've got a considerable amount of experience in data center optimization. When we began 12 years ago, cooling optimization really got very little attention in companies from a data center point of view and from a cost point of view. Back then, the approach was, if they felt there were cooling issues in the data center, it was just, let's throw some more cooling at it, let's buy another cooling unit, whatever it takes. But very few people looked at actually doing an optimization on it. So over the last few years, more and more companies, fortunately, are starting to realize that data center operating expenses and the outlay for new equipment can be substantially reduced by improving their cooling efficiency. We've continued our commitment to cooling optimization and energy efficiency in data centers, and over time, we've further developed this focused expertise through training, licensing, professional association, and of course, we've had a large number of customer engagements, which are also very good from a point of view of gaining additional expertise. We are a solutions provider, not a product vendor. We take a whole systems approach to optimizing the data center and resolving problems that are costing you a lot of money, and sometimes this cost is being incurred unknowingly. We dig into the root cause of the problem. We don't have a preconceived notion before we walk into the data center. Our objective is to go in and understand how the data center is operating and come up with a solution that meets your needs and meets your budget. And our objective overall is to end up with a data center that's compliant with ASHRAE recommended guidelines. We've worked in a variety of data centers, telecom sites, large enterprises, not-for-profit organizations, hospitals, colos, etc. So we understand the company's management dynamics, and we worked in quite a variety of dynamics. We provide a turnkey solution. We do the project management of all the activities and communicate directly with you, so you know what's going on at all times. Essentially, when we begin the project, we look after it from start to finish. As I say, we are communicating with you constantly. If you have concerns, we address those concerns very upfront. And our objective is that when we do a closeout of the work that we've done for you, that includes a walkthrough and includes considerable documentation of everything that's been changed, and therefore you know what the state of your data center is at that point in time. There's no surprises at the end. We refer to our program as cooling optimization. So what's that really mean? And we'll come up with a definition for that. And essentially it equates to using the least amount of cooling capacity and energy to create an optimal thermal condition for the IT equipment. And even though our focus is on cooling, IT equipment, we realize, of course, is the critical aspect of the data center. That's why the data center is there. That's why you have a data center. So our objective is to make that IT equipment give us as good an environment as possible for that IT equipment to operate. So what's that mean? Well, first of all, we optimize airflow, which allows the least amount of cooling capacity to be used to meet the needs of the IT equipment. And by reducing cooling capacity or operating cooling capacity, we reduce the cooling energy costs. And usually our results are very substantial reduction in cooling costs. And as I say, the primary objective, though, is to ensure that the IT equipment is operating in an optimal thermal environment and that operating costs have been reduced. So over the last few years, we've decided to start tracking some of the projects that we have completed. And if we look over the last 2 or 3 years, to date, we've achieved 7.8 million kilowatt hours of energy reduction. So to put that into terms that easier to understand, that's equivalent to about the energy consumption of 820 households in a year. We've saved our clients just about 1.1 million in energy costs for cooling, and that's a one-year value. And the reason I say that is because once we've helped customers achieve that energy savings in year one, the objective is that those savings continue to accumulate year over year. So the value here is just a one-year shot. Any project that we get involved in, we work with the client and work with the IESO to get energy incentives for that. And well, all of our projects that we've done have been projects that have been incented by the IESO. So that means that you, as a client, are getting money back based on the project cost and based on the energy savings that we've achieved for you. And to date, we've achieved close to $800,000 back to our clients, which helps to offset the project costs. On average, if we look across all of the sites that we've done over the last 3 years or so, cooling energy reduction has been on average 36%. So when we look at the cost of a data center operation, as I noted earlier, cooling can represent between 30 to 60%. If we take a number, let's say 40%, we're looking at about anywhere between a 15 to 20% reduction in overall operating costs for a data center. So that's pretty substantial. As well, we've also had an impact on the carbon footprint by reducing active refrigerant in cooling systems. And to date, we've removed over 3,300 kilograms of refrigerant, taken it out of service. And that is equivalent to about 6,200 tons of CO2. So needless to say, cooling optimization, number one, is very positive from a customer point of view. Number two, it's very positive from an environmental point of view. And number three, the intent here is to provide you with long-term results that you continue to see those savings. To put a slightly different perspective on it, our cooling optimization program, we've worked in a variety of data centers, colos, large data centers, small data centers. In the colo side, typically our average is running about a 40% energy reduction, and we've averaged about 274 kilowatts of additional IT load enabling this IT load to be added to a site without the addition of more cooling on that site. In large data centers, we've averaged about 30% energy reduction on the cooling side, and across the data centers that we worked in, it's resulted in about 242 kilowatts of additional IT load being added. Some data centers are more, some data centers are slightly less, but that's just an average across the large data centers. And when we use the term large data center here, we're looking at centers 7,000 to 8,000 square feet and above, even 10,000 square feet and above. We've done work in data centers up to 40,000 square feet as well. So the expertise and the application of cooling optimization is not just focused on one specific type of data center, but is applicable to data centers of all sizes. And then on the smaller data centers, so we'd be looking at 5,000 or 6,000 square feet and less. Our average cooling energy reduction has been about 41%, and the average enablement of IT load is in the range of 103 kilowatts. So for a small data center, that's pretty significant. So how do we achieve these results? Well, we created this program called Cooling Optimization, or COP, and it's a multi-step program, beginning with both creating an understanding of your needs and conditions of the data center. So we need to spend time with you as the data center manager or facilities manager to understand what's going on in your data center, how it's being used, what the objectives are, what the forecasts are for growth or forecasts for downsizing are, where you see some of the issues that are occurring in that data center. So we dig into the root causes of the cooling issues to understand and create a plan of action. And this data is collected we do on-site visits, very extensive on-site visits, and also the use of monitoring and metering systems, which would include the EkkoSense system. So based on this data collection and analysis, we put together a technical and financial feasibility, which is actually a business plan or a business case. And the whole intent of this is to give you the information that you need to determine what do I proceed with from an optimization program point of view. Clearly, our objective is to make that site operate as efficiently as we can on the cooling side. However, in some cases, you may not have the budget to do that. So our recommendations would include what you can do, and the recommendations can be implemented over a 1 year or 2 year period if that fits in with your budget. The purpose of the business case is to give you a tool that you can take to your upper management to let them know, here's what should be done, here's what it's going to cost, here's what the savings are, and here are the timelines. So it's effectively a means of making the right decision for your data center, and you know what the results are going to be prior to starting the work in that data center. If the business case is approved, then we get into the solutions delivery. And as I mentioned earlier, that is a turnkey delivery of the recommendations that we've put forward. We deal with all the contractors, the vendors, to ensure the right solutions are implemented and the installation is done correctly. We're very particular about how our solutions are delivered and are implemented within your data center, and our objective is to make the installation as smooth as possible, but also make it as efficient as possible. And then the final stage, and where we're going to spend most of our time in the presentation today, is what we call the COP maintenance, or the cooling optimization program maintenance. How do I continue those how do I continue those savings over the long term and ensure that I don't fade back into practices that we're doing before, which were not very energy efficient? And this is really where the real power of the EkkoSense platform shines through. It's providing information on the site cooling, power monitoring, capacity conditions, and it enables you to make any additional changes and recognize issues before they become serious problems, while still maintaining the overall energy efficiency. Part of what we do as well in the data center, we understand it's a very complex environment. It's influenced by many factors. And to create an energy efficient data center, the whole data center must be addressed. So we've created what we refer to as an ECM toolbox or toolkit, which includes a variety of energy conservation measures. And depending upon what's going on in the data center, what the conditions are, what needs to be improved, we select from this toolkit in order to come up with the proper or the best ECM. We've covered off in previous webinars to some extent considerable detail on the ECMs. One of our last webinars, we also did a presentation on applying 5 ECMs in a data center and what the results were of that. All of this information is available on our website. You can download and watch any of our previous webinars at your convenience. So the ones I've highlighted here today are the ones that I would say are used quite often. The airflow optimization, which is, it's not just management, which to us is the separation of cool air and warm air in the data center, but it also takes it a step further and goes into the optimization. How much air do I need going to my IT equipment so I can again meet the definition or objective of the cooling optimization being the proper amount of cool air going to the IT equipment. We don't want to put excess air out there, but just the proper amount of air that's required to cool the IT equipment. A lot of cases we get into the networking of cooling systems, which then in turn leads us into sequencing of crack units. And in many cases, we've gone in and done work in data centers, and data centers, when we walk in, are operating with 8 cooling units. The customer believes they have problems, cooling problems in that data center. They're looking at purchasing another crack unit in order to add more cooling. And by the time we're done with our cooling optimization program, we can show that customer that that site can clearly operate and operate much better on 5 crack units or maybe even 4 crack units, which means that they don't incur that additional cost for new capital equipment, and they've also saved a considerable amount of money. Tied in with that, of course, we look at doing, depending upon the vintage of the crack units as well, we look at doing cooling tech upgrades. We've sent out, again, information on our website is available on that, which we refer to as a floating head retrofit. And that's taking a slightly older version crack unit and replacing some of the original components with new components, which are being used in the newest crack units on the market, and making that unit operate more efficiently. And here we've seen considerable energy savings. And we've done, to date, we've done over 225 crack units with that floating head retrofit, and it's been extremely successful. And then we look at operational settings. So what's the temperature, what's the humidity set points that you have on your crack units? How much can we push those up? Because the higher we can push those from a temperature point of view, the more efficient your cooling unit is going to run, and equally so, the less energy it's going to consume. So when I say go back to airflow optimization is a bit of an iterative process that we go through here. Airflow management is what I would say is a single stage. So you go in and you put in the blanking panels, you put in the cold aisle, hot aisle containment, whichever it is. Maybe you put in some additional perforated tiles. We do that. That's all part of the airflow management. But then once we've gone through and do the rest of the work that we've identified here, once we've used the rest of the tools out of our toolkits, the appropriate ones, we then go back and do airflow optimization, which means given I've improved the management of the air, given I've improved the temperature, how much can I dial down the airflow in that site and optimize the amount of air that's being delivered to the IT equipment. So what we do is not a one-step process, it's an iterative process, and it does take some time, and certainly using a tool like the EkkoSense tool, it makes our life a lot easier because we see in real time what's going on within the data center, and we can actually see it remotely as well too. So we know that there's things that could be improved upon, so we can make it as energy efficient as possible. So I'll jump into the polling questions, and Dean, I'll ask you for some of your comments as well once we go through this. But based on the results of all the attendees that responded to our questions here, cooling capacity and level of cooling utilization were two of the main topics of concern with people. And from my point of view, I'm not surprised with that, because in a lot of cases, it's difficult to know how much cooling capacity do I have, and equally so, how much of that cooling capacity am I using? Cooling and cooling systems are very intricate, very complex, and to just say, well, I've got a 20-ton unit or a 30-ton unit in here, or 4 or 5 of those units, really doesn't tell the whole story. You've got to know a lot more about the systems, how the systems are operating. And I think something like, again, back to the EkkoSense tool, I think that would be a very powerful tool to help customers understand not only the cooling capacity, but also the level of cooling utilization. The other point, which was close to this, was airflow management. Again, that's all tied in with cooling and tied in with optimizing your data center to the maximum amount. So, Dean or James, I don't know if you have any any comments you'd like to make on those?
No, not really, Arnold. I mean, the good thing is the EkkoSense platform, so we'll demo it very shortly, but I mean, it's really easy for me to say that it helps address all of those polling questions. But we've obviously tailored our presentation to really focus on cooling capacity and level of cooling utilization. But I think it's fair to say we see exactly the same challenges from our other customers outside of Canada and the types of customers that we deal with. So they are absolutely the typical types of questions and challenges that all of the customers that use our platform see and that challenge us with. So yeah, fits really well with the demo we're about to do.
Right. Okay. Well, with that, Dean, I will turn it over to you and let you go through the introduction of yourself and James and the EkkoSense company, and provide people with all that good information.
Okay. Thanks, Arnold. Thanks to you and the SCTi team for inviting EkkoSense to join you on the webinar today. More importantly, thanks to all the folks on the call for joining today. I really do appreciate you taking the time out of your busy schedules. As Arnold mentioned, my name is Dean Boyle. I'm CEO, co-founder of EkkoSense. I'm also joined by James Kirkwood, who's head of critical services here, and he'll be doing the interesting bits. I'm just going to set the scene, do 2 or 3 slides, very brief slides, just to give you a couple of minutes on who EkkoSense are, types of customers, and really just set the scene for James to do the demonstration. So just a little bit about EkkoSense very briefly. We are, as you can probably tell from the accent, we're a UK-based software business. We have a very unique, intuitive, SaaS-based software platform, and we deploy that in all areas of the globe. Our customer base, so just to give you a bit of reassurance and confidence about the types of customers, include some of the largest data center operators in the world. We work across most verticals. We have a substantial number of enterprise customers, so end-user operated data centers, colo, wholesale, telco, and very large infrastructure operators. We have been doing data center optimization works, hence why we're a really good fit and why SCTi are a great partner for EkkoSense. But we've been doing a similar thing with our software platform for many, many years now, so well over 20 years in data centers and other critical facilities. And we've got this PhD level thermal engineering skill set, and we've combined that with, hopefully you agree, a unique platform that we'll show you shortly, and some hardware sensor technology and some integration skills to optimize data centers, as I say, for a long, long time. They are always with very compelling results and associated ROIs. Outside of the UK, briefly to touch on, we deploy via a global partner network, and SCTi in Canada are absolutely one of our closest partners, and we work very closely with them. Again, just a couple of very brief minutes on the core EkkoSense proposition before I will hand over to James who will do a demonstration. We've developed an extremely intuitive software platform. It uses data from our own unique sensors, combines that with other data sets or sensors if available and if we can get those data sets. And then the platform uses analytics, machine learning technologies to drive data center optimization activities to, I mean, ultimately it delivers 3 benefits, a combination of usually all 3, but certainly at least 2 of remove risk, save energy, release capacity. So ultimately, everything we deliver and we support our partners with and customers with, it's always risk, energy and capacity in some form. As we briefly touched on when we were looking at the polling results, for today's webinar, we're largely focusing on the optimization and cooling capabilities, thermal capabilities of the software. But it is also worth mentioning that the software has extensive M&E capacity management, power management and operational functionality. It's not the focus of today's webinar, but we can please follow up with SCTi as required if that's of interest. So focusing on the optimization and cooling elements of the software, it was interesting to see those polling results, and as I say, it just tie up very nicely with the demonstration we're about to show you, but we can also help with some of the slightly lesser important than the polling results. I'm probably preaching to the converted on this webinar, but our software helps address very well documented challenges in the data center: thermal risk, energy consumption, capacity management. And from the analysis and data across hundreds and hundreds of engagements that we've worked on, we typically see that there's a huge over-provision of cooling. So Arnold mentioned this in his slides. We typically see average cooling utilization, despite most cooling, all cooling units being on and working flat out or switched on. We typically see cooling utilization at around about 38%. Cooling is obviously a huge consumer of energy, typically quoted at 35% in most reference guides, but we often find that the true figure is much higher. And interesting, again, just in terms of risk, there is always at least one or two areas of very, very high risk that we see when we look at all the data. And typically we see at least 15% of racks are outside of typical ASHRAE guidelines for inlet temperatures. And also, again, pointing back to risk, roughly a third of all unplanned outages are down to some kind of thermal stroke cooling issue. These challenges that are typically the main drivers for engaging with EkkoSense, in addition to some of the slightly less tangible benefits, such as corporate carbon reduction initiatives, simplified capacity management, and certainly in these times, so never great to provide a service in these times, but the remote visibility in a COVID world, we've seen a lot of engagement where customers have been unable to, or partners have been unable to get access to site, or they just need additional remote visibility. So that also drives quite a bit of engagement at the moment. And that consistent management and visibility across the estate. There's also just that final point on that slide. It's interesting that I saw an internal stat very recently from our software team that we are processing about 50 million software data points on a daily basis at the moment. Finally, last slide from me before I hand over, you'll be pleased to know. I'm not going to go through all of these points, but it really is just to help set the scene again before I hand over to James. We typically see 5 main areas or 5 core requirements to allow you to do effective software-based optimization activities and to maintain that optimized state. Obviously, we need lots and lots of data. The more data, the better. So it's crucial that you have access to multiple, very granular data sets using either very new technologies, new sensors, which obviously we can help with, or just as importantly, using existing sensor technology or loggers. So if the customer has invested a large sum in third-party sensors, we will gladly integrate with those and take those into the platform. Visualize. So there are lots of tool sets available: DSIM, CFD, BMS, EPMS, etc. They all have their uses, but it's really important that you're able to visualize in a very straightforward way multiple, potentially complex data sets. And just as importantly, you need to be able to crunch that data and visualize at speed. Otherwise, it's very difficult to do effective optimization. The data also needs to be suitable for a multitude of different audience types. So that could be C-level exec, energy manager, operational teams, capacity manager, etc. And they are typically we engage with all of those customers. Analytics naturally is at the heart of the EkkoSense proposition. So the ability to augment measured, tangible data sets with machine learning algorithms and analytics to really take that complexity out of it to give really intuitive, tangible results and insights to the customer and partner. Then into the optimization. Now, I've ring-fenced the last 2 because this is the crux of the demo today, but it's vital that you provide actionable recommendations to support these incremental changes, and they need to be easily validated, and you want to continue this iterative process until all optimization objectives are met. And as Arnold mentioned, really importantly, it's never or very rarely just a one-off exercise. It's really important that you have the capability to deliver continuous optimization to enable you to keep up with a dynamic, ever-changing facility. And these last two elements are certainly where we're focusing on today. So finally, you'll be very relieved to hear that I'm going to stop now, hand over to James, who will demonstrate the EkkoSoft platform and hopefully show you how effective it can be to support optimization activities.
Great. Hello, everybody. As Dee mentioned, I am James Kirkwood, Head of Critical Services. So I'm just going to give you a demonstration of the platform, a live demonstration of the platform. Hopefully that's coming through okay. There it is, good. So as mentioned, we have a web-based platform, cloud-based web-based platform for managing critical estates, telco, data centers, etc. So this bringing cooling, space, and energy data from multiple data points and sensors, all viewable off your web browser remotely anywhere in the world. So from your phone, your tablet, or your computer or laptop anywhere in the world, you can see your global estate as well as drill down into individual sites and then also drill down into individual elements within your data center. First, when you first log into the software, as you can see here, you see what is our global dashboard. So there are two elements to the dashboard. On the left-hand side, you see any alerts coming through on your dashboard. So all your sites listed here. And on this demo example, live example, I've got 6 sites listed up here. And any key alerts or alarms, be they thermal or faults or power alerts, all coming up here. And on the right-hand side, you then have your leaderboard, so live KPI metrics such as PUE, compliance against service level agreement, SLA, live metrics about how your site is actually performing, temperature, etc. For this demonstration, really I've got about 15-20 minutes of demonstration. I'm going to just quickly go through the key elements, again highlight particular focus around the cooling capacity and utilization, but just introduce you to other areas of the software as well. So what you're seeing here from the dashboard, what I can do now is I can pick and drill down on a particular site. So I'll just take the first one, for instance, and I just click on it. And then you have a very quick pop-up which shows you the live, more granular information about the live performance of the site. So thermal information about the site, power information. So you also pick up power information, so your current power usage and your draw. And then also capacity utilization, so cooling, space, and power utilization. So you can see here site power, UPS back utilization, DC utilization, cooling utilization. So based on the data we collect from the site, this particular site is using 53% of its cooling available, and also space as well. So this particular site has space for 24 more racks could be placed in that site. So from this point, I can then have a look at my site power information, or I can visit the room. For this part of the demonstration, I'm just going to go visit the room. So I'll click on that. Just take 2 seconds just for that to load up. So what you are seeing now is a live view of a data center or switch floor. What I'm going to show you first and foremost is I'm going to show you the viewer section. So that is the day-to-day operational view and the monitoring part of the software. And then I'm going to show you a bit more about the capacity and the advisor. So not only are we monitoring the data centers and their historical and live performance, but we're also taking it a bit further. So the software itself does analytics on that software, and there are 2 key outputs of that. One is the cooling advisor, which gives you live advice on how you can improve the performance of this data center based on the machine learning that the software has been taking. So moving grills here, changing set points, etc. The next one is the capacity section as well. So that's using, again, all the metrics we were saying we're collecting. It tells you where you can and you cannot put loads within your environment from a cooling, space, and power element and capacity element. So the viewer element of it. So the first and foremost thing to say, the colors in here representing temperature. So this is a live view of a data center floor, as you can see in 3D. So the colors here are representing temperature. Very unique sort of a USP of the EkkoSense system. As you can see already, our visualization is extremely important. So we're collecting a lot of data points here. So in this, we collect data every 5 minutes. So there must be about 3,000 data points in this particular hall being collected every 5 minutes. So you understand to visualize that data is really, really important. And how we've done that, and very unique to us, is that we've actually took half of our software team are actually games designers. So this actual whole platform was built on a games engine. So that means we're taking all that learnings about visibility, usability, and speed, all from that stuff, from the software, from the games industry, and bringing that into the data center. So as you can see, this is a live view. I can first-person view as well, so I can walk around your data center live in virtual reality, point at things and understand how they're performing, all live. And that's due to the gamification, and you'll see that visualization, simplification all the way through the demonstration. So as I listed before, we've got at the moment you're seeing the live thermals, the colors here representing temperatures, but I've got many other filters that I can show as well. So I'll show you in racks. I can see things like humidity. I can see things like as well. I can see things like power usage. So if you have, it's not essential, but if you have intelligent PDUs, I can see how much they're drawing. So if I hover over that rack, I can see that it's 22 degrees C, 31% relative humidity, and a measured power of 0.5 kilowatts. Or I can click on a PDU, for instance, and I can pick up all the readings from that PDU. Or I can pick on an air conditioning unit, and there are loads of information we're getting from an air conditioning unit. All that data being collected every 5 minutes. And as I said before, you can click on any element, for example. So let's just click on a rack and then click on the reading. So I can just see what the temperature readings are over the time. So all the data is being trended. So we collect data, as you can see here. So we collect data, as I said before, every 5 minutes, and we store all that data for typically 7 years, but that contract can change based on the contract with a particular client. And one of the key elements of the software on the bottom is I can see all my data, performance data in a timeline. So if I just go back, for instance, I click on my timeline and I go back a couple of weeks ago, and I just see, I can go and click on my timeline, I can see how this site was performing in my timeline a couple of weeks ago. So you just jump back in time, so I can see here the site looks very different. And I can do a very quick split screen, compare and contrast my site, as you can see here on the left-hand side a couple of weeks ago, to the site as it is now. So it's very different, an unoptimized state. So it had some cold spots and some hot spots on the left-hand side, and now on the right-hand side, the room is looking a lot more well balanced. So I can, as you can see, I can do a swipe mode as well, so I can compare and contrast how I was performing very, very quickly. So I'll just put that back on single screen. So the next element I wanted to show you was the live information we're getting from the site, and look more focusing on the cooling capacity and the cooling utilization. So very unique to EkkoSense is we have a sensor or a range of sensors called EkkoAir, and that goes in each of the cooling devices on site, be they downflows or upflows or air handling units, different types. Doesn't matter what type of cooling system or cooling medium you use. We have a collection of sensors which universally pick up, and unique to us, they actually pick up live cooling duty. So they tell us how much cooling a air conditioning unit is actually delivering. Very unique to us. So if I just zoom in for a second in this example, and I'm just going to take away the racks for a second, just so it's a bit clear. So in this view here, you can see I've got 5 air conditioning units, and in this example, they're downflow units. And what we're doing, again, unique to us, is we're picking up actual cooling duty. So I'm going to click on the cooling utilization. So this is telling me live actually how much cooling these air conditioning units are actually delivering. And we know of no other product, software or hardware package which is actually providing you this information. So this view basically is showing me that the height of the grey box here is the actual total or nominal capacity of the unit, and how full it is actually how much cooling that unit is doing at the moment. So what that's telling me is these 3 units here you can see in the dark blue, they are delivering between 80% and 100% of their cooling duty. But the 2 units here on the left-hand side are actually delivering between 10 and 30% of their cooling duty. And that is being tracked all the time. So we can actually see how air conditioning units, how the cooling units are actually performing. What are they performing against their actual nominal duty? How are they affecting and changing as the room environments are changing? And again, this brings me into some of the analytics of the engine as well. But before I just go on to the analytics, you can see many different points here. If I show you, all this data is graphable, so I can see in this room, it constantly tells me, I've got downloadable reports, PDF reports, etc., that show you your constant utilization in your room, so you can see how well performing, either as a snapshot, but over time, you can see how well performing your cooling units are doing as well. All that is graphable, all that is downloadable as well, and tracked and trended. So the next bit, what I'm going to show you, as I said before, is the analytics. So the first part is that the software is constantly learning. So I'm just going to show you this cooling zones. So as I zoom in, what the software is doing is constantly learning the cooling performance and linking it to your rack performance. So the software starts to learn how effective cooling units are being in the rooms and their effective zone of influence. So this visual is showing you the software is learning through live and historical data that all these red racks cooled in red are predominantly cooled by this crack unit, red crack unit, ones in yellow by the yellow unit, blue in the blue unit, etc., etc. What it's doing is it's linking the rack data and the cooling data, and it's learning each rack, what cooling units cool each rack and to what level. So constantly learn the capacity within the rooms, not just as a total room, but within areas of the room and pockets in the room where are my actual capacity and availability. So as I zoom out, you can see here, and then what that also doing, the first thing that allows you to do is to understand the capacity of the cooling you have on the site, your true capacity, not assumed, but it also starts to bring in some other elements. So the first element is proactive failure. We can see and predict failure well in advance of a BMS system or any other system that typically pick up faults once a fan's failed or a compressor has failed, for instance. A BMS system typically will pick that up. But what we can do is weeks, if not months in advance, our software picks up abnormal behavior and can pick up and tell you that a unit is starting to fail or there are problems with the unit. So for instance, in this example, these 2 exclamation marks above the units are highlighting to poor performance of those rack units. So basically what that is showing you is that these units haven't failed yet, so there's no BMS failure, but our algorithms are showing us that these air conditioning units are not working as they should. And if you click on the units, it gives you more information about. But I can clearly see here that what the software's picked up is that you've got some warm areas of the rooms, but these particular units have not picked up that information, so they've not. They should be working harder than they actually are. So it's highlighting the user to some faults, and that could be compressor leaks, it could be spikes in compressor performance, which I mean the compressor is beginning to fail, could be stuck valves on a chilled water. There are many reasons that the software helps you and helps the user diagnose remotely some of the faults they have on the site, which is really, really important, particularly now in the era of COVID with less eyes on the sites. It enables someone from home to predict failure. Next thing I'm going to show you is a bit more on the cooling advisor. So based on all these metrics, we have the advisor module. So I'll just click on that. And that basically is taking all the learnings on the site, and then it gives you advice on how you can optimize the site. So it knows when racks goes in and rack goes out. So I'm just going to start that because it takes around about 30 seconds to run. So I'm just going to click that. So at this point, I tell the software what I want my SLA to be. In this example, 18 to 27 degrees Celsius. So I click OK. And then this is then analyzing the performance of the software. And on the right-hand side, will pop up some live examples of what you should do to optimize the performance of the site. So just take around about 30 seconds to a minute. And this is all about keeping your sites optimized. So as we work with the SCTi team about making that first off initial hit to save that 30% on average cooling energy saving on the site, this is about maintaining and keeping those savings as you go on. A few seconds. Great. So yes, so the software here has just highlighted certain areas in this room that can be of improvement. So first and foremost, it's highlighted some grills, and it's saying you should replace them with solid floor tiles. So we'll just zoom in there and it's telling me, it's highlighting particular grills it's found, and it's in this example telling you to replace them with a solid floor tile vent. Other advice is actually mentioning set points and on a handling unit, so it's actually saying that you could change these particular set points by degree, and it's also mentioning based on the resilience levels you set, it's actually saying that you can place a particular air conditioning unit on standby as well. So again, that's utilizing all the learnings from the live and historical performance of the site, and it's actually giving you advice on how you can improve the performance of the site to, 1, identify and remove rift, and 2, save energy. The next thing I want to show you is the capacity module. Just before I do, I just want to show you a bit of the background on the capacity module. So if I just go back to my main room for a second, what I can also pick up is when I clicked on the room earlier, I can also have a look at the site power. So although this is not the focus of this demonstration, I just want to quickly show you that we're not only picking up the cooling information and giving you live cooling utilization using our advanced analytics, but also can pick up power data. So this is a live power schematic of a typical site, and the right hand side it gives you very quick live power information and schematics. But along here you can see I can click on a UPS system, so I'm picking up the live information, so site mains through UPS, through PDUs, right down into the racks themselves. So the software not only understands the cooling side of your site, also understands the power metrics from rack through to PDU, through to UPS systems into site mains, and we also pick up DC power as well. So if you have more of a telco site, we can also pick up DC power. So the software is not only learning the cooling side, it's learning the power side as well. So if I flick back to the room, I'm just going to go into the capacity section of the software, load that up in the room. Again, take a couple of seconds while that loads up. Great, so that's loaded up. So basically this is a live view of the data center again, but this is the capacity view. So this is telling you your live capacity, cooling, space and power. So the first thing, there is some, on the very quick view on the bottom is some quick bar graphs, which are showing you here, the blue one is your cooling. So again, based on the information, live information we're picking up from our sensors, we're giving you the actual true cooling performance of the site and your true cooling capacity. So this graph is basically telling me that you are currently utilizing 70% of your cooling in this room. You've got 5% reserved for the future. The white line is your resilience line, and it's actually telling you have 85 kilowatts of cooling available in this room. In this example, the green is your UPS back power, and actually the software is warning that at the moment you're utilizing 70% to 9% of your UPS power, but it is warning that based on your reserved future use, you're actually warning that if you bring in all the power that you possibly plan to in the future, you will go over your UPS allowance. DC is DC power, and then the red one here is total site power. So you can clearly see here that your limiter on this one is your power, but not only that, you can also look with individual zones in the room. So again, our software, unique software analytics give you live information about where in the room is best to place loads. So for instance, if I click on any of these blue ones, which are reserved ones, so I click on a rack here, for instance, and that is a 2 kilowatt rack, what I can do is I can maneuver that around the room. So it says the word accept, which is just popping up on your screen. And I move that around the room. The software is constantly analysing whether you have cooling, space, and power availability in the room. So as you can see here, it's rejecting. So it's rejecting based on cooling. So what our software, unique analytics software, is telling you that in that particular zone, it's rejecting you putting 2 kilowatts of rack in that space. So even though you've got 85 kilowatts of cooling space as a total room, it's actually in a particular zone, in this particular zone here, it's saying reject. It's saying it recommends you do not put another bit of load in this area of the room. But over here, for instance, you have got cooling space and power availability. So if you wanted to, you could place that rack there, and that would not be a problem. But over here, it is a problem, and it's picked up that that's a problem because you don't have cooling availability in that area. And that can be because in that particular area of the room, you don't have cooling performance, so there's a low amount of nominal cooling capacity, and it's picked up that you've got poor performing on airflow restriction in this area of the room, and or you also may have high density equipment in their room and low density equipment elsewhere. And again, very quick demo, but I just wanted to show you again how easy it is or how to edit the room. So another problem or an issue that clients often come up with, particularly with BMS systems or other systems in the market, is how do I keep my site updated? It's really, really complex. Well, because of the gamification of our software, we've made that really, really simple. So if I click on an example of a room here and I visit the room, if you want to add or remove racks, really, really easy. We made it very simple drag and drop. You don't need to be an expert to maintain and keep your rooms, maps and plans updated. So all I simply do is I go into editor mode if I have permissions. I just unlock my map. On the left hand side, a library of parts appears. So the little cog appears. So let's just say I want to add a rack. I click on a rack and let's just say I want to put a rack here. That's in. And maybe I want to copy that rack, make a few copies. Maybe I want to move it around the room. Maybe I want to spin it around. Simple as that. Or change its dimensions. Really, really simple, really easy to do. And if you add our sensors on it, you just simply put your the 6-digit code in there, press enter, and that's it. You are monitoring. And maybe I want to delete a few racks because they've gone. So simple as that. And as I said before, all this is automatically recorded in the history of the site. So all this information, any changes you make, is automatically recorded and recorded in the asset database, so you can make changes at any time. That was it really. That was the end of a very quick whistle-stop demonstration. We're more than happy to run through further demonstrations in the future, or more in-depth demonstrations. But I'm just going to hand over to Arnold to talk about next steps.
Okay, great. Thank you, James. I appreciate that. And Dean, thanks. Clearly a lot of information there in a half an hour or so, or a few minutes more than half an hour doesn't give it justice to present everything that's there and all the capabilities that you have. Did we have any questions come in off the floor? I wasn't monitoring those. I don't know, Mark or Mediev, any questions that we could address?
I have been quite busy, yes, answering quite a few questions here. You know, one of the ones that just came in now is how intrusive is the implementation and hardware requirements here on a typical site?
Yeah, really very easy. So there's one, if you've got, we can link to existing sensors that exist and typical protocols, Modbus, SNMP, BACnet. That's one option. But we also got a range of our own wireless sensor technology, which are really unintrusive. So the sensors typically just simply tie wrap or cable tie onto the front of the racks, and they're wireless, and they speak into wireless hubs. On a typical 300 rack site, you've probably got 3 wireless hubs in a room. They all talk into what we call an Ekko Link device, which is our on-site one-U aggregator device, and then that pushes the data, encrypted data, into the cloud.
The information that James went through there, we clearly didn't have time to get into that level of detail in this presentation, but certainly, yeah, it's quite interesting to see how the system can be set up and how easily it is to set up and how it interfaces with other components as well. So that's all something that we could do for if anybody's interested. A future presentation specifically to your organization in order to show you what a lot more detail on the EkkoSense product and how easy it is to implement it within an organization.
Yeah, that's right. I mean, there are so many questions here as well. Like, where is the compute happening? Is it local? Is it cloud? Where's the data stored? Can you monitor other pieces of equipment or assets like UPSs and generators? You know, and we can answer all of that. Everything is in the cloud. We can monitor a variety of different assets. But yeah, James, unfortunately, in this time had to focus pretty much just on the white space here.
Yeah, that's right. Yeah, just to add to that, you're correct. So all the typical assets you expect in a data center, power and cooling, all the mechanical and electrical components we pick up, intelligent PDUs, UPS systems, mains incomers from a power perspective, temperature, cooling information, absolutely all the typical M&E assets that you have in the data center telecom state are in the software.
Well, we're just about at the top of the hour. I appreciate all of our attendees coming in and taking part in this presentation this afternoon. Certainly special thanks to James and Dean for taking the time and going through this, and clearly a very powerful system. And coming at it from an optimization point of view fits in really well with any customer that's concerned about, number one, getting their data center optimized, keeping it optimized, and continuing to reduce, keep energy costs under control and know what's going on with this data center.
Just to echo what you're saying, thanks everybody for joining. As you said, Arnold, we've touched on some of the functionality in the software. Some of the questions coming in, I know your team will follow them up and will support you with anything that you need, any more detailed questions about architecture, sensor types, and the types of questions that normally come in. But just thanks everybody for listening.
Great. But again, I emphasize the fact that feel free to get in touch with us if you want more information on this system. We, being SCTi and EkkoSense, are more than happy to do a tailored presentation to your organization and answer very specific questions that you may have. We will be following up any of the questions that we weren't able to answer today online. We will follow up with responses to those questions. And please let us know if you're interested in scheduling a time to discuss not only EkkoSense in more detail, but also the cooling optimization program and how we can help your organization become more energy efficient and certainly help your organization reduce operating costs substantially. So with that, thanks again, everybody, and have a great rest of the day. Bye-bye.